We are here to help.
Please note, there are variations in how Q1 and Q3 of a box plot can be calculated, so always refer to your own course to ensure you are learning the method your instructor has taught. Let's look at one of these methods. The goal of the box plot is to visually divide the set of data into 4 groups or quartiles, where each quartile contains an equal number of data points or observations. Let's consider the following list of 12 numbers in our example. The first thing we want to do is to sort our list of observations in numerical order from smallest to largest. In order to complete the box plot, we need to calculate the values of Q1, Q2, and Q3. Let's start with Q2, also known as the median or the 50th percentile. We first have to determine the location of Q2, which we will call L2 in this example, which is calculated using the formula L2 equals n plus 1 divided by 2, where n is the number of observations in our list, in this case 12. So if we substitute n equals 12, we get L2 equals 6.5. This means that the location of Q2, our median, is in the 6.5th position of our ordered list. As we can see, the 6.5th number is not actually a number in our list, but rather the value exactly halfway between the 6th and 7th observations. To find the actual value of Q2, we would need to calculate halfway between the numbers 29 and 36. The total distance between 29 and 36 is calculated by subtracting 29 from 36. But if we only want half of this distance, we would need to multiply this difference by 0.5. To find halfway between 29 and 36, we add this half distance on to 29. This gives us a median of 32.5. We are now ready to calculate Q1. Again, we need to first find the location of Q1, which we will call L1. The formula for calculating L1 is L1 equals n plus 1 divided by 4. Substituting n equals 12, we get 3.25. This means that Q1 is in the 3.25th position of our list of numbers, or a quarter of the distance between the 3rd and 4th observations. Following the same procedure we used to find Q2, we calculate the total distance between 14 and 23 by finding the difference, multiplying this difference by 0.25 to find a quarter of it, then adding it on to 14. This gives us a Q1 of 16.25. Finally, to find Q3 or the 75th percentile, we first locate L3 using this formula. Substituting n equals 12, we get 9.75. This means that Q3 is in the 9.75th position of our list of numbers, or 3/4 of the distance between the 9th and 10th observations. Following the same procedure as before, we calculate the total distance between 39 and 43 by finding the difference, multiplying this difference by 0.75 to find 3/4 of it, then adding it on to 39. This gives us a Q3 of 42. The interquartile range, or the IQR, measures the range of the middle 50% of our values. In other words, the distance between Q1 and Q3. In this case, the interquartile range is 25.75. Before we can draw our box plot, we need to identify any potential outliers. An outlier is a value that is either much larger or much smaller than most of the numbers in our set. Let's visualize this by plotting our numbers on a number line. When looking at this visually, we can see that 85 is likely an outlier. 2 or even 6 might be outliers, but we don't know for sure until we confirm the actual upper and lower limits given by the following formulas. A lower outlier is a value that is more than 1.5 times the IQR below Q1, And an upper outlier is a value that is more than 1.5 times the IQR above Q3. Substituting in the appropriate values, we get a lower limit of negative 22.375 and an upper limit of 80.625. This means any numbers in our list that is less than negative 22.375 or more than 80.625 are considered outliers. In this case, 85 is the only outlier we have. We are now ready to draw our box plot. Using the same scale we had before, we would draw vertical lines above our scale corresponding to the values of Q1, Q2, Q3, lower limit if there were outliers, and the upper limit if there were outliers. Since we don't have any outliers on the lower end, we can simply use our smallest number as the minimum. Create a rectangle by connecting the lines at Q1 and Q3. Connect Q1 to the minimum and likewise from Q3 to the maximum. Any outliers would be represented as dots beyond the minimum and maximum lines. You now have a completed box plot.